Okay, we're going to go ahead and get started. Good afternoon or good morning, depending on which time zone you're joining us from today. Thank you for joining today's HVAC webinar co-hosted by Spiral Pipe of Texas. We appreciate you guys taking the time out of your day and joining us. Today's webinar topic that we're going to cover is the science of insulating ducts. My name is Brennan Hall. I'm the HVAC product manager for Johns Manville Insulation. I've been in the HVAC industry for 7 years, the last 2 of which have been with Johns Manville. My co-presenter today is Steve Dockery with Spiral Pipe of Texas. Steve, go ahead and introduce yourself.
Good afternoon, everyone. My name is Steve Dockery with Spiral Pipe of Texas. I have been in the HVAC business for a total of 40 years, 31 of those years here at Spiral Pipe of Texas, which means I've seen a lot of specs, a lot of duct, and a lot of drawings, and I'm also really old.
Thanks, Steve. We're happy to have you here today.
Thanks.
At JM, many companies market what they make. We market what we stand for. At JM, our 4 core values are people, passion, perform, and protect. And we believe that by working and living those values each and every day, we're able to deliver to our customers what we refer to as the JM experience. We hope that sessions such as today's webinar help set JM apart in the marketplace and help you, the customer, receive the JM experience. At the end of today's session, you will receive a survey to provide feedback on whether or not we provided you with the proper educational experience. We really value your feedback, and we ask that you please complete and submit that survey in a timely manner. Now I'm going to let Steve give you guys a little bit more background on Spiral Pipe of Texas and who they are.
Thanks, Brennan. Spiral Pipe of Texas is a nationwide fabricator, manufacturer of sheet metal products. We've been in business for 36 years, specializing in HVAC ducts and fittings, specifically spiral, round, oval. We also make rectangular ductwork, sound attenuators, big industrial duct, custom sheet metal work, and thermal and acoustical panels, and we are pleased to be a part of this presentation today. Thank you, Brandon.
Thanks, Steve, and we're really excited that you're here today, and we appreciate you guys joining us. I'm going to go ahead and start out with the insulation introduction. Reasons to insulate. We insulate to solve many different problems that you're going to see in the world today. Things such as condensation control, freeze protection, process control, fire protection, noise control or acoustics, energy conservation. These are all the basic core needs of why we insulate in today's world during construction projects. Relative to HVAC systems and how they work, we're going to go through and kind of give you an example of how HVAC duct systems are set up. In this example here, you can see that the central equipment will draw in air from the outside of the building via fresh air intake in example A. It will then move itself over into figure B here, where fresh air is mixed with recirculated building air, or the plenum. Within the plenum, the air is conditioned, filtered, heated, or cooled, and then is distributed through supply ducts, as shown in figure C, and runouts within the building into the occupied spaces for occupant comfort. Then in figure D, you'll see that the return ductwork creates a path for the stale air to be drawn back into the system and recirculated, reconditioned, and then sent back out into the system. Insulation selection and material performance. One of the main reasons insulation is important is for temperature control and occupant comfort. Here we see how ductwork with insulation helps control temperature across the length of a duct section or system. In this example, 100 lineal feet of ductwork, both insulated and uninsulated, are installed in an 80-degree plenum space. In both diagrams, you can see the air coming off the unit or coil is 55 degrees. The bare sheet metal duct in the top diagram shows a temperature gain of nearly 10 degrees, while the insulated sheet metal in the second diagram shows merely a 2-degree increase across the length of the system. Obviously, insulating ductwork absolutely makes a difference relative to temperature control within a space. Insulation for HVAC ductwork is typically manufactured in R values of R4, 6, and R8. Insulation can play a very important role in occupant comfort and temperature control within your facility. Information and temperature control on thermal performance can be found on our new engineers portal at jm.com. This quick reference tool will provide you all the data that you need with minimal clicks to reach all the information. The exact link is listed below the chart, and you can find this at our website, jm.com. A second performance criteria that is necessary for selecting insulation is acoustics or acoustical control. In this example, we see how multiple factors can play a part and influence the noise in a building relative to acoustics. Obviously, starting at the fan, where you can have fan noise. As you move down the ductwork, you'll have airflow noise. As you get into the occupied spaces, you can have adjacent spaces where crosstalk noise can be transferred across ductwork. And obviously at the diffuser, where the air is being delivered into the room, all can create noise in the system. One of the ways to measure or account for acoustical control is duct noise attenuation loss, or the arithmetic average of sound absorption coefficients at the frequencies of 250, 500, 1000, and 2000. In the below chart, you can see how a section of bare sheet metal or wrap sheet metal provide very little or no acoustical value. Below those, you can see where duct liner or a fiberglass duct board provide excellent acoustical attenuation coefficients relative to those systems that don't have insulation or are wrapped. Another measurement to use for acoustical control is the NRC rating, or noise reduction coefficient. The noise reduction coefficient is a rating 0 to 1 used to describe how well a material absorbs sound. 0.0 theoretical is perfect reflection of sound. 1.0 theoretically is perfect absorption of sound. So for example, John's Manville Line Acoustic RC duct liner at 1 inch thick has an NRC rating of 0.7. That means it will absorb approximately 70% of the sound and reflect the remaining 30%. There are some other things that can, when it comes to insulation, that provide and help impact and improve acoustical control, one of which is insulation thickness. For example, I'll stay with the Line Acoustic RC duct liner. Duct liner is typically manufactured in half-inch increments ranging from half-inch all the way up to 2-inch. As you increase in thickness, your insulation receives a better NRC rating. The type of insulation application also makes a big difference in playing a role in acoustics. As we showed before, duct wrap or unlined metal have very little acoustical value relative to that of duct liner or duct board. Something else that can also play into acoustics is the length of the ductwork. There are some other materials that are available, such as turning vanes or sound attenuators, duct silencers. Those are all items that are complementary that can also be used in a duct system to help sound or reduce airflow and the noise. Just as before with our thermal performance chart, you can also see that we have an acoustical performance chart. Within the JM Engineer portal, all your acoustical needs can be found located within the charts. You will notice here that the Microlite EQ insulation or duct wrap insulation does not have any acoustical value. That's because, as we discussed before, duct wrap has very little impact on acoustics within a duct system. All this information can be found at the website below or at jm.com. Another selection criteria to consider for your duct insulation is energy efficiency and sustainability. Duct insulation helps maintain consistent air temperatures within the ducts, requiring less energy to meet the thermal needs of the building through controlling temperature loss or gain. In the below chart, which was provided by NEMA, we see the cost of wasted energy relative to several different types of duct applications. In this example, the cost of wasted energy across 50-foot sections of duct is evaluated. Let's take a look at some of the key highlights of the chart. I think one of the most important things to look at is the very first section where you're comparing unsealed metal ductwork to sealed metal ductwork. You can see that the leakage on the unsealed metal ductwork is considerably higher than the sealed metal ductwork. Moving down, let's compare sealed metal ductwork to sealed metal ductwork that is lined. The energy cost per day per that 50 foot of ductwork shows a pretty drastic decrease between the sealed metal and the metal that is insulated or lined. You'll notice almost a 59-cent per day per 50 foot of duct is energy cost wasted. If you extrapolate that same 59-cent per day per 50 foot of ductwork across the course of a year, there will be a $215 cost of wasted energy that is accounted for. Building on that theme of energy efficiency is sustainability. JM recently completed our Environmental Product Declarations, or EPDs. EPDs are comprehensive reports of the complete product life cycle. You can find these at jm.com or on the UL JM product page. We've completed EPDs for duct wrap, duct liner, HVAC equipment insulation, pipe insulation, OEM board insulation, as well as mechanical spin glass board insulation. The fourth criteria for selecting the proper insulation is condensation control. In the below diagram, we see a bare sheet metal duct in an 80-degree plenum space. The air coming off the coil is once again 55 degrees. In this scenario, any plenum with relative humidity greater than 45% will result in the duct having condensation or sweating. A simple solution for this is a vapor barrier and insulation thickness, depending on the product. As I mentioned, vapor barriers or vapor retarders are materials that limit the transfer of water vapor across assemblies to 1 perm or less. The effectiveness of a vapor retarder is expressed in perms or permeance. A lower perm rating means less moisture flow. Properly wrapping one side of the insulation helps control condensation when sealed by the appropriate methods. Some of the common or typical facings that you'll see within HVAC or mechanical insulations are FSK or foil scrimcraft, PSK or poly scrimcraft, or ASJ jacketing, which is commonly found on our pipe insulation. For more information, we've got a blog that we've written at jm.com about the many facings of insulation, where you can learn a little bit more about our facings and the different types of facings that show up on insulations. When it comes to thickness selection for condensation control, obviously duct liner is an important product where thickness matters. One of the nice features about duct liner is antimicrobial coatings, which help prevent mold and fungi growth on the insulation. Coatings like Permacoat, Johns Manville's proprietary surface coating, are designed to inhibit microbial growth on the surface of the insulation. Code and specification compliance. Codes: the International Mechanical Code, or IMC, the International Energy Conservation Code, the IECC, and the Uniform Building Code, or the UBC. These are all code bodies that dictate mechanical requirements such as fire and smoke safety, how material should be installed, and what R values are necessary for the insulation in a required geography. On specification compliance, the National Fire Protection Association, or NFPA, tests for surface burning and fire characteristics and the combustibility of insulation products. Underwriter Laboratories, or UL, they kind of lean towards specific test methods for flexible duct or duct board, and their test methods ensure materials meet the performance criteria that is necessary. And then you have the American Society for Testing Materials, or ASTM. ASTM develops a lot of test methods for materials such as mold growth, corrosion, fire performance type characteristics. I think it's important to remember the difference between certifications and standards. Standards such as UL or ASTM are design requirements that are necessary for the project. Certifications such as SCS recycled content, EPDs, lead points or credits, Green Guard certifications are optional design considerations that are not required or necessary in all cases. One criteria that we see specified a lot relative to duct liner especially is density. In the 1970s, TEMA, or the Thermal Insulation Manufacturers Association, which has since evolved into NAMA, the North American Insulation Manufacturers Association, published a standard called AHC-101-1975 for fiberglass duct liner. This standard addressed a number of critical characteristics that are still highly regarded today for duct liner performance, but it also was the genesis for standardizing liner density and specifications. The thought process behind standardizing liner density evolved from the practice of using insulation density as the primary selection criteria for duct liner. At the time, industry professionals assumed incorrectly that all liners perform equally and that density was the key differentiator in insulating performance. The flaw in this logic is that all duct liners do not perform equally. In fact, design differences employed in manufacturing process technologies and airstream surface treatments are what influence insulation performance. Therefore, density has little relevance to actual duct liner performance. Generally, using outdated density specifications will often result in increased material costs without actually addressing the acoustical and thermal performance requirements of the project. In 1986, insulation manufacturers and ASTM recognized that all duct liners are not the same, so they attempted to rectify this misconception by approving a new standard for duct liner selection. ASTM C1071, the standard specification for fiberglass duct lining insulation, was created. When this new standard for duct liner selection and specification was established, density was no longer listed as a required attribute. The performance-based ASTM C1071 duct liner standard removes the guesswork from the selection of duct system liner insulations and provides the engineer, contractor, or building owner the freedom to focus on comprehensive duct liner performance rather than liner density. This means that you, the engineer, can write specifications based on acoustical performance, thermal performance, corrosive potential, fiber erosion resistance, surface burning characteristics, and other key types of duct liner performance characteristics. We also have a blog that's available that we've written on this. We see this very commonly. It's one of our most common technical questions that we have to answer. The blog is at jm.com, Performance-Based Duct Liner Selection. I would encourage you to check that out and visit that on our website. The next thing that's important to talk about is the safety of fiberglass and HVAC systems. Biosoluble insulation fiberglass presents no cancer hazard. It is safe to make, install, and use if recommended work practices are followed. Ideal tools for the job are long pants and shirt, gloves, and eye protection, which can help avoid temporary mechanical irritation. Fiberglass is by far one of the most tested man-made materials in the market. Multiple studies confirm that respirable glass fibers used in JM insulation do not persist in the lungs because they are biosoluble. There's a lot more information on this. You can visit our exclusive content section on our website where you can find a webinar that we've already created on this, on fiberglass health and safety with our own Bruce Ray. Insulation selection, fiberglass duct insulation. I'm going to pause for 1 second and let you guys know that if you have any questions, you can feel free to submit those questions in the chat box to the right of the screen, and we will address these questions at the end of the session. Fiberglass duct insulation selection. So relative to duct liner insulation, obviously duct liner is designed to insulate commercial, institutional, and residential sheet metal ducts. In the diagram here, you can see how a sheet metal duct is adhered and lined and pinned and mechanically fastened inside of a rectangular duct. You can find all the standards for the design and installation of sheet metal ductwork in the SMACTA HVAC Duct Construction Manual. They have a lot of really great information in there, and they'll talk about nosings, pin schedules, things like that. When it comes to ductwork, you can have rectangular or square, or you can have spiral and oval duct. There's two types of applications for insulating spiral duct. The first that I'll talk about is double wall spiral pipe. In the example you can see in the top right-hand side, you can see a double wall pipe section. The yellow insulation is wrapped around an interior core that can be perforated or solid, depending on the application, which is then inserted into an outer casing of spiral pipe. This is a tried and true method for insulating spiral pipe. It's been around for a long time. It's in the SMACTA Duct Construction Standards, but the one thing that can cause problems is it is heavier, and it has the potential to have a higher cost depending on the diameter of the pipe. On the bottom left, you'll see a product that is a spiral duct liner that is a pre-kerf liner engineered to insulate virtually any size of round duct. Johns Manville has a product called Spiroacoustic Plus. It is equal or better in thermal and acoustical value relative to double wall, and it can reduce the weight by almost 30% across the length of the system. Johns Manville Spiroacoustic Plus also has a coated airstream surface that has the antimicrobial coating in it to help prevent mold growth and fungi. Duct Wrap is a flexible blanket product that is used to be applied to the exterior of commercial ducts or plenums. Typically used in a temperature range of 40 degrees to 250 degrees, Duct Wrap reduces heat loss or gain through duct walls and helps control moisture condensation. As we spoke about earlier, you got to remember that Duct Wrap has no acoustical benefit for your system. I also want to point out the silver facing here is what we refer to as FSK or foil scrimcraft. There are some insulations that are also used in residential primarily. There are some commercial applications for flexible ducts and ductboard, but we predominantly see those in residential applications. But flex ducts are an efficient way and an economical way to install connectors between trunk ducts and room diffusers or registers. It's an inner core wrapped with insulation with an outer jacketing. It's very flexible. And ductboard typically comes in a 4x10 sheet and is used, and it can be pre-grooved or cut into the ductwork itself. With that, I'm going to turn it over to Steve Dockery from Spiral Pipe of Texas to go into some of the duct system components. Steve, take it away.
Thanks, Brad. All right, we're going to talk a little bit today about the duct system, how we get the air from the unit to those diffusers, and some of the things we run across on a daily basis. First of all, the duct system requirements, minimum characteristics. The duct system must be constructed and installed to meet applicable building codes, must comply with warranty requirements of the HVAC unit manufacturer. The conditioned air, heated or cooled, must be delivered to the occupants within the building, because it doesn't do much good to have a nice, pretty air unit if the CEO of the company in his corner office is hot because he's not getting any air. The ideal characteristics of that duct system, no leakage of conditioned air or return air. Conditioned air temperatures must remain constant. How we do that is insulation. Fan, air rush, and crosstalk noise are not transmitted through the ducts, usually through duct liner. Duct system size and design to maximize HVAC unit performance and energy savings. Duct designed to provide required airflow to the conditioned areas. We're going to talk a little bit about the different types of ductwork that we see. Spiral ducts. We have round and oval ductworks made out of spiral pipe. The benefits to the spiral duct system is less leakage than a rectangular duct. That mechanically joined seam of that spiral pipe is almost airtight. So you have less leakage than a rectangular duct, less sealing of that duct system is required. Spiral duct can use lighter gauges than an equivalent rectangular duct because that seam also gives you quite a bit of reinforcing of that ductwork. Usually it's a faster and less expensive installation cost, mainly because you can use up to 10 or 12 foot lengths of ductwork versus a 4 to 5 foot length of the rectangular duct. One thing I didn't put in there is any of you that have been to a sub shop or the Dallas Cowboys Stadium know that the spiral duct is used more in exposed locations. I think most people think that it is aesthetically pleasing a little bit more than seeing some rectangular duct. So the drawbacks to spiral duct is the contractors that are installing this duct must purchase this, most of them, rather than make it. So there's an increased cost there for those particular contractors. Larger sizes of round and oval duct only come in even number diameters. So that may affect some of your airflow calculations. That's usually not an issue airflow-wise in sizes over 36-inch round. There's not a whole lot of difference in the amount of air that can move between a 61-inch round duct and a 62-inch round duct. Rectangular ducts. The benefits to the rectangular duct is most installing contractors, sheet metal shops, can manufacture their own ductwork. There are more liner options for the rectangular duct as far as thicknesses without having to worry about adjusting duct sizes. The energy efficiency standards don't impact the duct size and capacity. So in other words, if you have 1.5 inch duct liner installed in a 24 by 24 rectangular duct, it is not an issue making that outer shell of that ductwork 27 by 27 OD. In spiral duct, without some changes, if you have that same 24-inch round duct and you're putting 1.5 inch liner in it, then all of a sudden your OD is 27-inch round, and a lot of spiral manufacturers do not make those odd sizes above, say, 25. Again, in the larger sizes, that's usually not an issue. Some of the drawbacks to rectangular ducts. As stated before, there's more leakage than in the spiral duct. All of those seams and all of those joints in that rectangular duct have to be sealed. There's more field connections. Again, you're running a 4 or a 5 foot piece of ductwork versus a 10 or 12 foot piece of duct in the spiral, and every place you have a field joint, every connection is a potential leakage spot. Typically, it's a higher installation cost for the rectangular duct for that particular issue right there. And the fact that you're making more field joints, it's taken your field installers a whole lot longer to put it in. All right, specifications and designs. Go through some of the things that we see daily here. Optimizing duct sizing. System leakage to prevent oversizing of ducts. If the duct is properly sealed, then we're not the designers are not having to oversize that duct to allow for that leakage. I think we're going to see more and more jobs on a daily basis requiring that all these ducts be sealed, even the low pressure systems. A properly sealed duct system allows you to properly size your equipment. The fans, you're not having to allow for duct leakage. The air handling units, the same thing. So a properly designed duct system will allow you to undersize or properly size that equipment, which of course is going to be a lot less expensive. If you're having to upsize your air units or your exhaust fans to allow for that leakage, that's just another extra cost that we're seeing today. Understanding sheet metal gauge. Sheet metal gauge is a relationship between the size of the duct and the static pressure in that system. The goal of a properly designed duct system is to use the lightest gauge metal, which of course is going to be less expensive, without allowing duct failure. The benefits to the lighter gauges is less weight and a cheaper cost. Offsetting that a little bit is sometimes more reinforcing is required to keep that ductwork from failing. And as we said, if you're using lighter gauge, you're increasing your chances of duct failure. Heavier gauges, the benefits to that, again, heavier and more expensive because you're paying for extra weight. However, less reinforcing of a particular duct system is going to be required, and a decreased chance of duct failure. How do we decide what gauges to use on our ductwork? Typically, it is by the SMACNA standards. SMACNA is the Sheet Metal Contractors Association. Their standards are results of years and years of testing and real-world uses. My experience with SMACNA goes back to when I first began in this business. I think the first SMACNA manual I saw was dated 1976, although we still saw some that were some specs referenced to 1969. And I can tell you, over the years, all the way up to the latest manual, which I think is 2006, I've seen changes. I've seen the lighter gauges. I've seen the allowance of lighter gauges and more reinforcing. And you know, SMACNA is in the business of designing these things, these standards, to allow the sheet metal contractors to use the most economical systems that they can. And trust me, they're not in the business of being able to send out ductwork that as soon as you turn that exhaust fan on, it's going to suck it flat. That doesn't do anybody any good. Okay, mitigating duct leakage system. We're seeing more and more systems requiring a 1% leakage. I was really interested in one of the charts that Brendan had earlier about energy efficiency and sustainability, where it showed the unsealed metal with a leakage of 216 CFM and the sealed metal at only 27 CFM. So you can see right there the savings that's going to come from sealing of the ductwork. And we're going to see it more and more and more as the years go on. Sealing of the seams is stated earlier, not required on the spiral pipe. Now the fittings and the joints of any spiral system are still going to require duct sealer or a flange connection or something to seal that system, but the seams in the pipe itself do not require it to be sealed. Fewer connections in a spiral system, like we discussed earlier, because you can run longer sections, is going to allow less field joints, less opportunity for that duct to leak. Conversely, rectangular duct's going to have more unsealed seams and joints. What do we look for in a properly sealed system? SMACNA Seal Class A is recommended for all systems above 3-inch water gauge. All transverse joints, all longitudinal seams, and duct wall penetrations will be sealed with the exception of spiral pipe. We're going to be seeing more and more of this Class A duct systems, even at the lower pressure classes. We've seen it up to date, and I think that we're going to see it even more and more in the years to come. Excuse me. Some of the engineering pitfalls that we see, lack of specificity. Which ducts are going to be lined? We see over and over again a specification that will address duct liner in a duct system, but then won't go on and tell us where that duct liner is going to be. How ducts should be manufactured, whether or not they are per SMACNA standards or per designer specifications, something that will lead the contractor or manufacturer into exactly how these ducts are going to be lined. If you have a special kind of system, say a dust collector, what static pressure is that running at? What type of any standard or heavier gauges that are required for that type of system? Where liner is required. That's probably the biggest question that is brought to me on a daily basis, is the fact that the specification talks about duct liner, but nowhere does it tell us where that liner goes. And I think probably how the duct should be manufactured and where the insulation is required is the thing we see on a daily basis. With the specification pitfalls, again, the outdated specifications. I actually saw a spec the other day that referenced, speaking of that SMACNA, a SMACNA 1976 low velocity duct construction standards. Well, they, there's been a lot of years and a lot of improvements in those standards since 1976. And if that particular manufacturer or contractor is required to actually build the duct to that standard, then we're wasting money, because it's a lot heavier gauge. That duct system is going to be a lot more expensive. And I think one of the things that can really eliminate that is to state in the specification that it is in accordance with the latest edition of the SMACNA standard. Incorrect specifications, like Brennan was talking about earlier, in lining densities, we still see a lot of specifications that require or pound-and-a-half density liners, or 3-pound duct board, things like that. We see at times requirements for round double-wall ductwork with a 3-pound liner in it, which is an impossibility. The liner for the spiral duct has to be flexible enough to wrap around the ductwork. And if any of you guys have ever seen any 3-pound liner, you're not going to wrap that around anything. It's pretty stiff stuff. Generic specifications, again, I think I understand we're all busy, and sometimes it's difficult to really get that job specific, but we see a lot of jobs that obviously the specifications don't match up with that particular job. I remember seeing not too long ago a big hospital job, and it talked about using duct liner where exposed in a gymnasium or auditorium. And to me, again, that was a spec that was used on a school somewhere and was just stuck in on this particular job. Another problem that we see a lot of is something is specified, say a duct liner or a special material, say for an exhaust system where they're specifying some aluminum or stainless steel duct. And then you get to the drawings, and there's notes on the drawings that contradict that. And I think that is an age-old question that I can remember asking the man who taught me how to do this was, okay, which takes priority, the notes or the specification? And he didn't have an answer for me. And I'm not sure I have one today. I do know that it takes time away from contractors, fabricators, and designers having to answer those questions to decide which is right, the note on the drawing or the specification. All right, targeting good design. Again, the SMACNA, the manual guidelines, talks about the load on the system. How much air can we move through those? The sheet metal connection types. What type of connection goes with what static pressure of system? What type of connection goes with round versus rectangle? The gauges that we're allowed to use for those particular static pressure designs. R values in the insulation, and what codes that we must follow to have a duct system that is in accordance with everything that we need to go. The highest priority clarifications are going to be the gauges of the metal, the types of joints, where the duct liner is required, and what type of lining, and also the required construction and material standards. I've been doing it long enough that I know that if I see a chemical fume hood exhaust system in a university, chances are good that that's going to be some kind of corrosive resistant metal, usually stainless steel. However, if that is not listed in the specifications, then it's difficult for, without getting clarification from the designer, it's difficult to bid that as stainless steel, because the difference between cost of galvanized and stainless steel materials is huge. That puts the fabricator and the contractor in a bad spot. Sorry, Brent. Some of the often overlooked details of duct design. Space constraints. This doesn't seem like it would be that big a deal, but you know, if you're talking about a hospital and the amount of equipment, medical gas, oxygen, all that stuff that is in the ceiling space where the ductwork is running, if we're specified at an 1.5 or 2-inch duct liner, and that drawing shows the internal dimensions of that ductwork, and say we have a 24 by 24 duct again with 2-inch liner in a return duct specified. Now all of a sudden we have a 28 by 28 OD duct, and sometimes squeezing that in there can be a little bit tight. So some of those things that we need to take a look at and make sure that they're accounted for. And one of the other things that we really see that you wouldn't think would be that big a deal is we see more and more requirements for sealing open ends of ductwork as it's delivered to a job site or on the job site with plastic wrap to keep dirt, dust, water, everything else out of it. And the more and more leads jobs we see, you know, these are requirements that are done. You know, but however, a lot of this plastic material, when it's taken off the ends of the duct, is wadded up and thrown in a dumpster and ends up in a landfill somewhere. And so how do we look at that versus any protection of the ductwork in a leads job versus the amount of plastic that's going in a landfill somewhere? I'm not sure I have an answer for that, but that's just some of the things we see. All right, specifying the optimized fabrication, and this really has to do with, again, duct liners. When we talk about double wall duct, as we spoke earlier, that liner that is used in double wall duct must be flexible enough to wrap around that inner shell. So if you've got even a 10-inch round or a 40-inch round piece of ductwork, you wrap it in insulation, and then it is stuffed inside the outer shell. Well, the tensile strength of that liner must be enough that it's not tearing as you're wrapping around there. So it can't be too dense that it doesn't wrap around the duct, and it can't be too light to where when you're trying to wrap it around there it tears. Specifying high quality of insulation liner. We have seen, not with any of John's Manville products, fiberglass that has come in here that has basically unmelted glass in with the ductwork. So specifying a high quality liner is going to pay off in the long run. Specifications, detailed, current, and clearly understandable. The easiest spec I think you could put for a sheet metal man is just say per Magna standards, tell us where it's lined, and that seems simple, but again, those are proven standards that every sheet metal contractor in the United States follows if they're worth their salt. All right, some of the trending factors: energy efficiency standards, and of course increased R values equals increased thickness. This is not really an issue for rectangular ducts, except for, like we spoke earlier, in the space above the ceilings, making sure that that duct is allowed for if we're increasing the size of that duct for the liner. Spiral duct sizes also must be increased if it's lined. And again, like we spoke earlier, usually above 25-inch round, not a whole lot of spiral manufacturers are making those odd sizes. For oval spiral duct, which if any of you don't know how oval duct is made, it is you run a piece of round spiral duct and it is put on another machine that stretches it and flattens it out. So again, you are limited to the sizes that you can make. And I don't know of any oval spiral maker that uses minor axes of odd sizes. Now this really only applies when you're specifying 1.5-inch liners. Any of the 1-inch liners, 2-inch liners are not a problem. Again, allow appropriate space to run the ducts for the appropriate thickness of the required R value. And one of the big things that we see on a daily basis is confusion about R values that are required for exposed ducts in a conditioned space. We see this a lot. You know, what is the requirement? What is the R value for the ductwork that is exposed, say in a gymnasium or in a football stadium or in a sub shop? 1 inch of insulation is going to give you an R4.3. The 1.5 is R6.4. So depending on what your requirements are, the relative humidity of that space is going to determine whether we're using inch or 1.5. Finally, some of the things that the trending factors we're seeing are fiber-free liners. I know that this is being required in some buildings. I think a lot of it is being required by owners that aren't necessarily educated on what fiberglass is and what it can do, what it does to you. But I can guarantee you that they are finding out in a hurry when they see the cost of some of these liners. And in almost all cases, these are much more expensive than a fiberglass liner. I know of a company that manufactures a fiber-free liner that is made specifically to go into round ductwork, and in some cases that material is almost 10 times more expensive than going with an equivalent double wall duct or a spire acoustic type liner. And to me, that is ridiculously expensive. And again, I'm looking at it from a point of view of trying to save contractors, customers, owners money on their projects, and that to me is just not the way to go about doing it. In a lot of cases, these fiber-free liners are not providing the same acoustical performances or R values as standard fiberglass is. I appreciate y'all listening to me today and being a part of this. I would invite you, if you have any other questions, to visit our website. It's spotusa.com. There's a tag on there where you can get a hold of us if you need to. Also, you can see some of the projects that we've done around the country over the years. And I will turn it back over to Brennan. Thanks.
Steve, thanks you for sharing a lot of your information and knowledge and experience with this today in the group. We appreciate that a lot. For those of you on the call, we do offer a certificate of completion for this webinar. These forms will be emailed out to you hopefully by the end of the week, more than likely by Friday. We do have some upcoming webinars we want you to be aware of. We're doing another one on April 12th around the fiberglass health and safety piece that we've spoken to. And then on April 19th, we're going to be doing a mechanical system Ask the Experts forum, kind of a roundtable session with several industry experts that can take your questions rapid fire and answer them back. For more information, you can obviously find them at our website, jm.com. And with that, I'd like to thank you guys for your time today. We know your time is valuable, and we appreciate you spending that time with us today. My colleague, Kim Melton, has been monitoring questions for us during the session. And Kim, do you have any questions for Steve or myself today?
Yeah, thanks, Brennan. So our first question is, there's a little bit of confusion around the difference between liners and ducts. So can you get into maybe a little bit more detailed explanation about where those two distinguish?
Between liners and ducts?
Mm-hmm.
So duct liner is a product that goes inside of ductwork. It is typically it's glued and pinned inside of ductwork, whereas you might have a duct wrap that is it's a different type of product. It's a flexible blanket product with an FSK or PSK vapor barrier that would go on the outside of ducts. So duct liner goes inside of ductwork. Duct wrap goes on the outside of ductwork.
Yeah, the duct liner typically is used not only for R value, but if you want to cut down on the noise.
Excellent. So our next question is, if performance standards have not been updated, or have been updated not to reflect density as a measure, why are engineers still requiring density as a requirement?
I'll take that, and I'll let you elaborate on it too, Steve. I think from what we have seen, our sales team goes out and does a really nice job and does a lot of engineer lunch and learn calls and does a lot of engineering calls. One of the things that we get consistently feedback-wise is that most of their people, or when they do these calls, specifications just get copy and pasted from previous jobs or previous plans or drawings. Steve kind of spoke today about how he had a school or a hospital job that had a specification for a gymnasium in it. So I think we see a lot of just kind of copying and pasting things instead of being updated. We see a lot of situations where a master spec for the firm doesn't get updated with proper information and data. Those are just a couple of the things that we see where people, probably in a way to save time and do it quicker, kind of just not updating things and not properly specifying them. And Steve, do you have anything to add on that?
No, not really. I think that's it. In a nutshell, is using older spec or copying over from previous job, and maybe just the person in charge of that not aware that those standards have changed.
All right, Steve, can you speak also to a little bit about what maintenance is required for ducts in general?
Really, the only maintenance that might be required for ductwork, and depending on the application, would be cleaning. If the duct is properly installed and properly sealed at the time of the building is put in, they're pretty maintenance-free. You know, if it's hung and supported correctly, the vibration is not going to make those hangers fall apart, and if the duct system, the filters are working properly, the cleaning really doesn't even need to be done either. Only if it becomes an issue, and that's probably more an issue of the filters not doing their job. So really, a duct system, if properly installed and designed, is pretty maintenance-free.
All right, the next question. With regard to energy efficiency, what's the payback period for this application?
I think the chart, I'm looking through my notes here to look at the payback period. I think the chart was based off of a full year based on 50-foot sections of ductwork, if that's what you're speaking to, I think. And I know the chart that showed sealed metal versus sealed lined metal ductwork showed about for every 50 foot of cost wasted energy, there was about $215 per year saved, I guess you could say, or not spent relative to sealed metal versus insulated sealed metal. I don't know if that hits on that topic or not, but that's where I think you're going there.
Yeah, I think you could also add to that the payback period is largely going to depend on labor cost with the material used, as well as the basic requirements of the application and the size. So I think that's another feature that's going to play into it. Steve, do you have anything to add to that?
No, as far as the ductwork, you're going to be installing that. If it's a medium pressure system, medium or high pressure system, it's going to be sealed as it's installed anyway. So we're really only talking about low pressure systems, and a lot of things can be done to speed it up. You can seal those seams on the rectangular duct as you're knocking it together, and run a bead of sealant as you're slipping the S and drives together to make those field joints. So it's not a huge expense, and a good contractor, if he knows going in that he's going to have to seal all those seams and all those joints when he's putting it together, you know, it's really not that great. I don't think the payback on sealing the seams on the ductwork is really that great.
And one more added to that question, I'm sorry, is which is more expensive? Is it spiral or rectangular duct, and which one should I opt for? Steve, can you speak to that?
Well, I work for a company named Spiral Pipe in Texas. What do you think I'm going to say? But honestly, it depends on the type of system. This is an age-old question. Any sheet metal contractor is going to tell you that he can make the rectangular a whole lot cheaper, but when you put everything together, the fact of sealing of the ductwork, the longer joints, the longer pieces of duct, the less joints, I think for a medium pressure system, nothing but spiral should be designed. You just have less leakage, less opportunity for problems. For low pressure systems, downstream of a VAV box or just a standard low pressure system, I think rectangular duct is a fine product, even if it has to be sealed. But I think definitely for medium pressure systems, nothing but spiral should be used.
So one more question is, as we see more work being spec'd as unlined, how do we convince the specifying engineer that wrap will do nothing to actually eliminate the noise, and what printed materials do we have available to us? And Brendan, can you speak to that a little bit?
Sure. I think a couple things here. Obviously, we've spoken a lot to that in the webinar today. I think this would be a good resource or tool to use. And then really on jf.com on our website, I mean, if you go to the actual duct liner or duct wrap page, you'll see or the engineer's portal actually is where you're going to find all the information. You're going to have acoustical value charts. It's all going to be right there on our data sheets, our technical data sheets. There's not even a reference to acoustical performance chart, I don't think, on the duct wrap page, whereas the duct liner is going to show that there's an acoustical advantage there. So I think just utilizing information that we've got, things from this webinar, our engineers portal, I think those are all places where you can get information there. And of course, you can always work with our sales rep that's local. We have territory reps that are throughout the United States. They all have a specific geography. You can reach out to us and ask for some assistance from your local territory rep, and they have all kinds of different tools and things that they can use to help you as well to convince an owner that you need to look at the acoustical value of the insulation.
So here's one question. In order to have a quotation, what documents do I need to submit? I presume that that's a reference to an insulation quotation, but I'm not quite sure if they're speaking to that or actually the duct. So we'll probably have to get back to you on that one after the webinar. As for that actually concludes our questions. I'd like to remind everybody, as Brennan said, that you'll receive a survey following the webinar. And if you could just take a little time to offer your feedback on the webinar today, that would be greatly appreciated. Also, if you have any questions that you didn't actually get to ask, you can submit them via the survey, and we'll respond to you directly via email. Keep an eye out in your inbox for your certificate of completion. That'll go out to you by Friday. Also, we will be posting a recording of this webinar online, so if you missed any part of the presentation or you'd like to view it a second time, you'll be able to access it on our website. Otherwise, we thank you very much for your time and hope you enjoy the rest of your week.